3D laser scanning, a film created and presented to you by Salut Engineering Services in Oman. It demonstrates the technical advantages of 3D laser scanning, where speed, accuracy, high resolution, long-range measuring, and modularity represent the most important features of this state-of-the-art survey technology. Laser scanning displays even large objects in the most realistic and authentic way, such as petrochemical plants with their piping nets, for example, or natural and artificial landscapes like valleys, dams, roads, rail tracks, as well as urban projects like airports, building complexes, and huge construction sites, to name but a few. The image that you receive of the laser scanner consists of millions of measured points, a point cloud, where each point is referenced to in 3 dimensions: northing on the y-axis, easting on the x-axis, and z, which indicates the geographical height above sea level. This picture presents an old oil field with wells and pipes, the locations of which need to be scanned in order to establish an accurate 3-dimensional as-built drawing when the project owner wants to modernize the oil field or build more drilling rigs in shorter distances. Here it is as well important to establish the location of the underground piping system. Older plants and installations in the oil and gas as well as petrochemical industry. All over the GCC countries we find many older plants which have been built some decades ago. Meanwhile, expansions and moderations have been extended to these plants and no comprehensive and integrated drawings are available. Therefore, a 3D laser scan is required to obtain as-built drawings which allow to generate an electronic database of all technical details of the entire plant. These electronic database and technical drawings, which are derived from the scan cloud, will be the foundation for future expansion or moderation plans, as well as maintenance schedules and shutdowns. In this first section of the film, Musa, our lead engineer, is mounting and operating our 3D laser scanner. It is strategically positioned according to the predefined scan stations and then programmed for resolution, distance, and other key indicators. The scan data are recorded in the scanner and later on transferred to and processed with the specific programs on the computer. The results you will see in the following segments of our film. The scan of the Nizwa fort presents partly a top view image of the entire area, and you may think we fly over it. However, with the software we can tap into any 3-dimensional reference point, even as high as approximately 200 meters, as the scanner is taking a horizontal and vertical circumference image of its environment from its ground position. From the top you can recognize as well walls and the ground layout, which allows us to draw later on a detailed floor plan. Madinat Kalhat, an ancient civilization commanded by its famous queen Bibi Miriam. Today you see her tombstone and many excavations of old stately houses. Reference points above and below ground level give us a perfect overview of the entire area. Even you can see the dimensions of the water reservoir underground. Until now, the scans had been taken with a medium resolution of 10 cm up to 100 meters, meaning the scan measures every 10 cm a point on an object in 100 meters distance. A higher resolution of 5 cm on 100 meters, you can see a huge difference in detail entering Bibi Miriam's tombstone. From each and every angle, the building can be dissected and analyzed only by precise and accurate point cloud measurings taken by a 3D laser scan. The dam in Al Amarat is a fine example of man-made landscape, fully scanned in all its dimensions. You can easily recognize the side banks and the siphoning areas of the water stream through the topographical lines of the digital drawings. This scan of the old city houses in Ibra is displayed with its raw data. That means you can see around the main object, which is the house's front, trees, parts of the road, and other things. By processing the data, we clear the house's front from all unnecessary imagery clutter, so you can see the facade now perfectly. From the top viewpoints of the point cloud, we have also established a detailed floor plan. To detect all damages and cracks in the walls, this scan of the dilapidated house in Ibra has been taken in a specialized way by creating shadow measurements. We have shown you scans of different objects. Now you would like to know what results you get from such a 3D laser scan and how you can use it. We are now processing the scans and show you the results. The Tilal construction site in the middle of Muscat displays water channeling systems, embankments and a large excavation. To allow accurate excavation volume measurements for financial controlling and BOQs, a most accurate and detailed DTM, digital terrain model, as well as built drawings in any stage of the construction must be available. Because of its accuracy of ±3 mm, you can avoid financial disasters with a precise and correct quantification of, for example, excavation disposal materials or concrete pumping mass. During and after the construction, all data are stored and proof for any further development, as well as basis for claims verifications. You are able, with the free software that you get from us, to take exact measurements right on your PC without going on site. You can establish topographical features and finalize as-built drawings for completion of your planning procedures. Again, you don't need to go to site for any measurements. Remember, each point is three-dimensional and you get exact geographical references right on your desk. We show you again the Ibra scan that you saw before. It is now processed. The top image shows you on the left a picture of the house's front, whereas the corresponding scan image is a still snapshot of the point cloud. The middle image shows you the point cloud on your screen, which you use, again with your free software, to follow the contours of windows, doors, etc., and to establish a technical drawing of the real object. All details are authentic. So you can see, for example, on the left half of the point cloud image, the broken front walls with its remaining broken side, and in its opening, the remains of the back wall. The lower image of the house's front is the drawing with the lines derived from the point cloud image, which an architect may want to use to develop, for example, his renovation plans. Whether you need virgin areas, existing structures like old plants to be surveyed fast and efficiently, 3D laser scanning should be the chosen technology to save you a lot of money in the future. The processing software is TrueView. How it is used, what does it give you, we would like to show you in the following section of the film. Software TrueView. For a meeting in your office, you can prepare all data for your team members and show them on your laptop all topographical and as-built features of the project. This tutorial shows you the application of the software TrueView that is used to derive from a point cloud all relevant measurements and data. You see the cursor moving over the front wall of a dilapidated building. You see the key plan, meaning the ground plan with the scan stations, and when you click onto one of these stations, the program immediately opens the image of the point cloud that has been taken by the scanner at this very station. Then you take whichever measurements you like, as you can see in the examples with the doors and openings, as well as the road. An advantage is the exact determination of the 3D location of a point, in case you need to know its exact geographical reference. You may wish to know where and how extensive road maintenance needs to be done, so you establish the respective requirements in your office. We at Salut Engineering in Oman render as well other industry-related services to our clients, such as preliminary engineering and topographical surveys, cadastral and plot setting, vertical and horizontal structural controls and monitoring, and underground detection of metal and non-metal piping systems with the AML, our new NASA-developed material locator. Dear viewer, thank you very much for your attention, and we look forward to a successful cooperation in the nearest future. Your Salut team.